Number 34 is going to be pretty similar to one we worked on the previous page here. Instead of calling this whole thing x and then just this half piece 1/2 x, I'm going to call it a y for a moment. And then I'm going to redraw the radius of 3. And then we'll go y squared plus 2 squared equals 3 squared. We know since it's perpendicular and it's a piece of the radius, it must be a perpendicular bisector. So whatever y is, the other side will be y, and we can double it. So that'll get us y squared. That'll get us, what's that, 4 and 9. When we subtract, we'll get 5, and then when we square root, we really can't square root 5, so we'll just leave it as square root of 5. And kind of like the last problem, we're going to multiply by square root of 5, and it's kind of like a 1 out here in front, so this will be 2 square root of 5 for that full length of x there. So using Pythagorean theorem and then doubling again. Okay, 35, another quadrilateral inside of a circle. So previous page we talked about these here adding up to 180 degrees. That's going both ways there. So from right to left and left to right. So angle C, if we do 180 minus the 50, we'll get 130 for angle C. And then down here for angle B, 180 minus 91, 89 degrees. And that'll be it there on those. They do ask also for these arcs here, so I'm trying to cover the answers so y'all can't see them right away. But BD, what we'll go and do for BD, so B to D right there, that's that minor arc. That's across from angle 50 right there. So for the measure of angle, for the measure of the arc, DB, we're just going to go and do 50 times 2, which gets us 100. And then we'll basically rinse and repeat that process for each of the different arcs that they asked for here. They asked for the major arc ABC. Alright, so that major arc has these vertice points that goes back to angle 91 right there. So we'll just do 91. Let me make that look a little bit better. 91 times 2. What's that, like 184 for that arc right there for ABC. So that's that there. And then arc of DAB. Let's see what's going on here with that. So here's the D to A to B right there. That has the vertices here, D and B. That goes back to arc or angle C right there. We found angle C to be 130 after we worked it out. So we'll go do 130 times 2. That'll get us 260 degrees. And then that'll be it there on that. Oh, apparently I messed something up. Oh yeah, ABC should have been 182 there. My bad on that. Early in the morning, can't do mental math, I guess. Next one here, find the area and circumference of the circle. They want us to round our answers to the nearest hundredth. Can't remember on the test if we asked for in terms of pi or if we asked you to round, so I'm going to do both. Area formula is going to be pi r squared. So we're going to go pi and then times 2.1 squared. So if I ask you to leave it in terms of pi, really you just need to do 2.1 and then squared. That comes out to 4.41 pi right there. So this would be in terms of pi or the exact answer. Sometimes they'll say exact or in terms of pi. The approximate answer, usually we'll use little squiggly lines there for that. We'll actually do 4.41 and then we'll actually use the pi button. That is second and then raised to on the typical TI-84 calculators. That gets us about 13 let's see, they asked for nearest hundred, so 13.85 right there. That's the approximate or rounded answer right there. And then we'll go and get, of course, our units here. That's meters squared for both of those. So I believe that's, yep, what we got there. Circumference is 2 pi r. So basically 2 times 2.1 right there. And then put on your pi, that'll be 4.2, I guess, and then pi. It's kind of close there to the previous answer, but different formula. So that's your answer in terms of pi. And then 4.2 pi I guess I got it over here to the side already, but it's 13.19. And then that would be in regular meters. Since they asked for the nearest hundredth, really this is our best answer right here. But be ready for both. So I think we will ask you both there. Okay, 46, 47, they're asking us to find the length of the minor arc AB. Just in case they did ask for the major arc, just make sure you use, instead of 60 degrees, you use everything but the 60 degrees. You do 360 minus 60 to find that angle. Alright, and then this is actually on the formula chart as well. They have the arc length and the area of sector formulas right here. So for this specific problem, going to use this formula right here. The arc length, we'll just call it x. That'll be over 2 pi r, which is the circumference. And then that'll be the arc measure, the number of degrees right here, over 360. So basically it's a proportion. It's a proportion of the whole entire circle. So let's see what we got here. This will be x, and then over 2 pi r, or 2 pi times 6, and then equals 60 over 360. That'll be x over 12 pi. 360 over 360 you can reduce if you want. You don't necessarily need to. But then I would just go and cross multiply from here. This would be 6x equals 12 pi. If you're going to use your calculator, just type everything except pi in, and then just put the pi on to the answer at the end. So that should come out to 2 pi. And that was in centimeters. So that's going to be it there on that. 47, same thing, different numbers right here. So this will be x. I'm going to go ahead and do the 2 pi in my head. It's 2 times 18. That'll be 36 pi. And then that'll equal 150, and then over 360. And this is kind of like what I was talking about on the last problem. If you just want to use your calculator, just do 36 times 150 instead of the 36 pi. So that'll get you 5,400. And then just put the pi on at the end, and then you got 360x. And then we'll divide by 360. Apparently that gets us x is 15 pi. And then we'll put on our units there, 15 pi inches. If they didn't tell us to leave in certain terms, like in terms of pi or rounded, I would assume leave it in terms of pi. Okay. Last couple of problems here. Find the area of the shaded sector. You got a 90-degree angle, and you're trying to find this area right here associated with the 90-degree angle. That formula is different. It's on the formula chart here. It is this one here. The only thing that's really different than the previous formula is that you're going to use area down here, which is pi r squared. So let's go ahead and try it out here. Pi r squared, which would be 6 squared. And then 90 over 360. This would be 36 pi. 90 over 360, if you want to reduce it now, you can. It'd be 1/4. If not, then just cross multiply. You should still be fine. And after you divide, remember, don't type in pi into the calculator on this one here. This will get you 9 pi, and then that was in centimeters squared. That'd be your area there. Okay, only thing that's kind of interesting here about 49 is 49, we're finding the area of the shaded region here. So the 60 helps us get the angle we need. But on this one here, we need to do 360 minus 60 degrees here to actually find the angle that we're going to use here. We don't want to use the 60 degrees because that would find us this area right here, which is basically a gap. So we'll use 360 minus 60 for our angle. So this will be x over pi r squared, which would be 15 squared. 15 squared is 225, I believe. Double check that. Yep, 225, and then we'll put pi. And then now we'll put 300 degrees, and then over 360. And I'm just going to do 300 times 225, 6, 7, 500, and then equals 360x. Well, actually, you know what? 6, 7, 500 with pi. Technically, we're not really typing in pi though until the end. 187.5 and then pi, and then they didn't give us units, so I guess I'll call it units squared for right now. But That should be it right there on that.